Hi everybody, welcome back to the Feynman Technique. Today we're going to be solving an integral using King's property. No Feynman integration today. King's property is this thing, very easy to prove with a direct substitution. So let's get started. Alright, so the first thing we're going to do is immediately apply King's property. So let's see. That means that this is going to be equal to the integral. Well, King's property does not change our bounds of integration, but now we're going to have f of a plus b minus x. So that would be a plus b is pi minus x over 1 plus sine of a plus b, which is pi minus x dx. And sine of pi minus x is simply equal to sine of x. So this whole thing is equal to the integral from 0 to pi of pi minus x over 1 plus sine x dx. All right. And this is pi times the integral from 0 to pi of 1 over 1 plus sine x dx minus I. Adding I to both sides gives us 2I is equal to this thing, or I is simply equal to the integral from 0 to infinity pi over 2 1 over 1 plus sine x dx. And from here, it's not that difficult as long as you don't make any stupid mistakes like I just did. All right. Okay, so what do we want to do now? This is like maybe a bonus question on a calculus 1 final, maybe. So the first step is to multiply the top and the bottom by 1 minus sine x. So this is pi over 2 times the integral from 0 to pi of 1 minus sine x over 1 minus sine squared x, which is just cosine squared x dx. This is going to be equal to pi over 2 times the integral from 0 to pi of secant squared x dx minus pi over 2 times the integral from 0 to pi of sine x over cosine x dx. And on this second integral, we will make the substitution that that's a squared. U is equal to cosine x, therefore du is equal to negative sine x dx will give us the negative right there, making this a plus. All right. So let's see. We can see right here that this integral is going to evaluate to 0, because taking the antiderivative of secant squared x is just tangent x, which is 0 at both 0 and pi. So this whole thing goes away. So we're left with nothing but this. So I is equal to pi over 2 times the integral from, let's see, u is equal to cosine of x. So cosine of 0 is 1, cosine of pi is negative 1, and then we have, let's see, we have our du, and then 1 over u squared, so that's u to the negative 2 du. And that's going to be equal to, let's see, pi over 2 times u to the negative 1 over negative 1, evaluated from 1 to negative 1. Well, let's switch the bounds here. We'll make this negative 1 and this 1, and multiply the inner function by negative 1. So we just have 1 over u. All right, that's going to be pi over 2 times 1 plus pi over 2 times 1. In other words, that's just pi. All Alright, there you go. There's that integral solved with King's property.